kids in first hour said that they were out for tomorrow or something. I'm not sure, but I want to go through and do a few problems with you, showing you how to apply the two free fall acceleration equations. So we did this on Friday, and we look at this equation here, and I want to actually do some practice with you now. One of these equations said delta V was equal to G times T. And again, G we said was about 10 meters per second squared. It's actually closer to 9.8. And then there's other units that we could use as well, but I'm going to show you how to use that equation. And then also the one that talked about how far an object would fall. We crossed this one off, so if you were gone last week, you should see that in one of the video recordings, but this is the one that causes most of the issue. We said that how far an object falls can be described by that equation. So what I want to do with you today is I want to look at number one. I want to go through and show you how we might solve that one, and then this one here. And again, these are problems that involve free fall acceleration. You're not going to be quizzed on this. So the quiz that you take tomorrow is not going to have this kind of math. This is purely for your egg drop project, so you know how to do these things. So it's more of a long-term goal for us to figure out how to use these equations. So you may have seen in the video when I had the bowling ball and feather drop, they talked about Galileo's experiment on the Leaning Tower of Pisa. So Galileo's there, he's dropping objects off of this tower, and a light object, a heavy object, and both of them hit roughly the same time. And again, the distance is not that great, the speeds were not too great, and so they were able to show that heavy objects and light objects accelerated equally, or at least in a purely vacuum environment they would. Let's calculate how fast they were traveling at the time they hit the ground and how far they fell. So I'm going to do this with two different equations. My general approach on this is to make a list of the things that are given, and that identifies what equation I might use. So the time that they're given is 2.3 seconds. I might write that down and say that's how long it takes for it to fall. The acceleration the object's experience is equal to G, and I'm going to write that as 9.8 meters per second squared. And so it's asking for how fast they're going. Well, that question then is really just saying, what is delta V? How fast is that object hitting the ground? And so I'm going to use the version of the equation from the previous slide. Delta V is equal to G times T. I take that 9.8 meters per second squared and multiply that by 2.3 seconds. And again, for some of these, you're going to need a calculator, right? So I have calculators for the egg drop project. When you're doing this, you're going to use a calculator, you're going to use your Chromebook, whatever, but you need to be able to do this kind of calculation. So 9.8 multiplied by 2.3 gives me about 22.5. And that speed would work out to be meters per second. We'll lift that up so you can see it better. If you're struggling at all with those units, I'm going to show you how that works out here. If I write meters per second squared, and then I multiply that by seconds, I notice that one of those seconds in the denominator reduces, and that would turn into just meters per second. So, as we should expect, that speed would have units of a distance per amount of time. Okay, so that's where that unit comes in. Now, for the other question, it's asking how far would it fall? So that's a different equation. So I'm going to switch to a different color here. Again, the time is 2.3 seconds. The acceleration is still G, but now what it's asking for is how far it falls. So if it's asking for speed, I'm going to use that G times T. If it's asking for distance, I have to use that 1/2 AT squared. So the equation that I'd use, delta Y is equal to 1/2 the acceleration that it experiences times time squared. when I have to do a square there, I'm going to take that 2.3 and square it first. So 2.3 is squared is 5.29. I'm going to multiply that by 9.8, and then I'm going to divide that by 2. And I get 25.9. Now, when I look at those units, I see meters per second squared, and then multiplied by a quantity of seconds squared. And so that reduces to just 25.9 meters. So the distance that those objects would have fallen, about 25.9 meters, traveling at about 22.5 meters per second. So those two equations, I would use those to be able to determine distance of fall and speed. Not going to be assessed on the quiz with us, right? So we didn't feel that these were critical items for quizzing. Just want to have you have this for the project. Now, the one that I had you guys do on Friday, and a lot of people have these things turned in. Lauren, I'm going to use yours for a second. So the solution I had you guys do for us on Friday was you measured your distance that your ruler fell. I went through the math with you, and I don't know that everyone realized this. On Friday, I was having good. I had fun. You guys were looking like you had fun, but I didn't see a lot of people look at this set of equations. So I solved that for you to see how you determine how to use that equation to calculate time. But now, because I know not everyone saw that, I want to go through that with you here in class so you can see how you would use that equation. To test your reflexes, we might drop a ruler, see how far it falls. I would make a list here again of the things that are given. If it falls 23 centimeters, that's my delta y. Delta y 23 centimeters means it's changed its vertical position, our y value, by 23 centimeters during that time. I could just as well write that as 0.23 meters. Now, one of the things that we need to sort of get comfortable with is that the units that we use matter. We have to be concerned about what those units are. 23 centimeters is about that distance there. It's 0.23 of an entire meter. So centi is sort of short for century. You might think of century as 100. So there's 100 centimeters in a meter. So if we measure a 23 centimeter drop, that'd be equivalent to 0.23 meters. Why is that important? Because the acceleration that I use has to have the units that match that. I might write it as 980 centimeters per second squared, or 9.8 meters per second squared. It's important that whatever length I use, whatever measurement I use for length, they match the acceleration value. So I notice that the centimeter and the centimeter, the meter and the meter, those have to be consistent. Go ahead. They have to be consistent. Now I'm looking for time. So based on me knowing how far I dropped and the acceleration, I'm going to use this equation. The two things I know are the delta y and the g value. What I don't know is the t. So what I'm going to do algebraically is I'm going to solve that for t. So the first thing I'm going to do is I'm going to multiply both sides by 2. When I multiply both sides by 2, this becomes 2 delta y. Is equal to g times t squared. Next, what I'm going to do, since I'm looking for t, is I'm going to divide both sides by g. That becomes 2 delta y divided by g is equal to t squared. And then since I'm looking for time, I'm going to go ahead and take the square root of both sides. That becomes t is equal to the square root of 2 times change in y divided by g. Now, when I go to do this calculation, I just need to make sure that the delta y and the g are using the same units. If I want to use the 23 centimeters, that tells me I have to use 980 centimeters per second squared to be able to do that calculation. If I wrote 0.23 meters, I'd have to use 9.8. So I have to make sure those units match. And again, those that have a little bit more math background will see that the centimeters are treated like algebraic variables there. The centimeters reduce, and what I have is a 1 over second squared. That just becomes second squared. I take the square root of that and I get seconds. Now, my calculator is going to give me the 2 times 23 divided by 980. I did see a number of people put that number down, 0.047, but I have to take the square root of that, and I get 0.217 seconds. Pretty average reaction time is about 0.2-ish or so seconds, how long it takes for you to respond to that. Folks, that kind of math is not going to be on a quiz or a test. That's mostly for your egg drop project. So when you're doing your egg drop project and you're having to go through it, you can look at these things there to be able to help you get those calculations done. Okay? We felt most comfortable just having you have those resources there in front of you to be able to do those calculations, because we don't want to make it a heavy math class. Questions for me at all on that? You need practice on it. That's what these homework assignments are for, is just to give you some practice using those equations. Again, I grade them for effort. Just do your best on it. I'll look at those things with you tomorrow, and then we'll go from there. You have plenty of time to get that done. Okay, so you guys should have you should have 6 questions there. The 2 equations up on top, delta v is equal to a times t, and delta x is equal to 1/2 at squared. If you want to replace a with g, that's for free fall. And then just do your best on trying those questions. Okay, I'm going to look at your responses, those that were able to submit the responses. And if there's anything major there, I'll look at it, but I'll probably just pull the entire formative up and just go through it because of my error on that. Okay, I'm going to go ahead and stop.